as Jeremy said, my name is Collin Manchester. I'm here to talk with you guys a little bit about how you can correct your files for 3D printing using Materialise Magics. So Magics is a mesh editing software made by Materialise. The current edition we're on is 24. And Magics is a very powerful software for editing meshes, and it is specifically tailored for 3D printing applications. So its tools are focused to help you get your build files ready to send to the printer. So here's our home screen for Materialise. And I want you to take a second and think, if you're getting files from a lot of different people, usually there's some variance in the quality of those files. Depending on what software is happening, not everything is a watertight mesh. Not everything has greatly resolved triangles. Maybe there's some intersections. Maybe there's some inverted normals. And if we're exporting out of a CAD program, usually those are very minor issues, and whatever slicing software we're using can deal with the issues. But sometimes, and depending on what software we pull out of, those issues can be quite complex and much more than the error fixers can handle in those slicing softwares. So that is where Magics can come in and really help you. So to show this, here's a part file that would probably give a lot of slicing software some trouble. Lots of inverted normals, we've got some holes, and we've got some bad edges. So with Magics, we can easily go through and start fixing these. We have a large suite of repair tools and a large suite of selection tools to help us isolate the triangles we have issues with, either remove bad edges. We can come in and create bridges if we want a lot of control over how that shape gets repaired. We can fill those gaps. But that's a very time-consuming method and painstaking way to do this. So Magics has a few tools that really help speed up this process. The biggest one, and the one that I use, well, I guess we'd say second most, is the AutoFix tool. AutoFix is one click, solves and fixes all of the issues in our part. So one click is as easy as one click, and we can get to a fantastic part. This is a great way to quickly fix parts if you're trying to do quoting or something like that. But this is a pretty aggressive type of solution and just kind of blunt forces its way through fixing the part. So deal with that, Materialise also created the Fix Wizard. Now this is a guided workflow that shows you all of your errors and then allows you to start going through them one at a time, fixing things. So a great tool. It gives you a little bit more control and lets you have a little bit more information about what's going on with how your part gets fixed. If we ever want to check on our part, one click away on our home screen, we can get our part info. Oh, excuse me. And there we are, we're back. That didn't save my repairs. So we'll go through, fix that again. Here you can kind of see some of those triangles that can be issues just because of how aggressive this solver is. And the other tools like the shrink wrap tool can easily remesh our part and quiet out those triangles, or we can go through our Fix Wizard and make sure that they're not repaired in that manner in the first place. At this point, after we've resolved our issues, usually we're not done when we're trying to prep a file for printing. We got to take into account now what kind of build orientations we're using, what kind of printing method we're going to be using, what are our critical features, do we have interface components, how is this going to fit in our build tray, things like that. And one that would be utmost in particular for this, because this is probably going to print with some form of resin printing, is a wall thickness. And resin printing, we usually have a minimum wall thickness that prints successfully. So in Materialise, we have a wall thickness analysis tool. This allows us to define whatever wall thickness we have, or we care about filtering, and we can analyze our part so we can see, as this part stands, it probably wouldn't be a great candidate, as most of our walls are below 40 thousandths, or right about 1 millimeter. So in a lot of cases, this would require us going back to the customer or whoever sent us our file and saying, hey, I need you to make these changes. In Magics, we can skip that. So then we're not waiting for customers to get back to us or make these changes, which isn't always easy with their models. So we can directly come in and select faces or areas, surfaces that we know aren't thick enough. And we can use the extrude tool to quickly thicken those. In just a couple clicks. I'll run that shrink wrap tool again just to help clean up the faces. And then we can go back to our wall thickness analysis and see that this wall now is in a much better place for printing. The only place we have issue is right at the top where it's seeing that chamfer on this side. Not something we'd really worry about for printing. So that's what I have for this part. So we can see that there's some very powerful error fixing tools in Materialise and ways that we can modify our print without having to export and then re-upload into this software. Now, to show off some of the other tools, I have this composite core. Now, this is a pretty large part. And something like this, it would be pretty likely that we wouldn't want to print this part solid. Materialise has a few tools. We can both shell and hollow this part. We'll start off. Shelling works very similar to CAD programs. We select the face that we want to be our opening. Define our wall thicknesses. We can define our mesh size for that new surface we're generating on the inside. And then we let the machine think. The amount of time this is taking kind of give you an idea of the size of part we're working with, because this part is a pretty coarse mesh. This part, I believe, is a few feet long. And then we have our shelled part. Now the view tools in Materialise are also very powerful, and they can really let us see kind of what's going on. We can see these cross sections with our section lines. These follow our coordinate axes, and we can also set those on a custom axis. And we can even use them as a clipping method, so we can really see the inside of our part. Another great thing about Materialise is pretty much everything you do can be undone. Just Control Z, back and forth, apply, reapply, features and modifications. So it's really easy to catch any mistakes that may come up. So this time we're going to hollow our part. And we can go back in. So looks pretty much the same, but when we clear that clipping plane, both ends are capped. Now this would be an issue if we're printing with a vat system or powder-based. So we have another tool called Perforator. That we can easily add perforations anywhere we want on our part of whatever size geometry we're worried about. And we can even add locating notches. So that plug only fits in a single way. And we click and apply. Materialise even generates a new part for us for that plug. So you can leave this at 1 or add multiple. Quickly and easily for whatever your part may need. And it's all automatically generated into your parts. So this is a great tool that we can use for powder bed systems or for stereolithography printing methods. Now, let's add one final wrinkle about this part. Since it is so big, let's say it is exceeding our printing volume for what we can build. So that means we're going to have to build this in 2 pieces and then join them together. Materialise has a lot of tools for cutting parts. My favorite way to do this is using the section features like we're using to look on the inside of our part. These section lines can also be used to be a cutting plane. Materialise has a few ways of doing this. We can do off of a custom constructed line, or we can do teeth interface, jigsaw, square, triangular teeth, whatever best suits our application. We can even round these. So say we're working with an FDM system where those sharp corners aren't quite as desirable or achievable. But my favorite way, the sectioning tool, we either have basic joints, that's just a flat cut, lap joints, so we have that nice shoulder to come up against, or connecting pins. These connecting pins are a really powerful way because we can either do hole connections or pin and hole cuts. So either we're building that interlocking feature into our parts or leaving the cavity so that we can install dowel pins. So we'll go through, we'll cut, Materialise, automatically mixes up our colors so we know we have 2 parts. And we can come in here and look at our interface. A couple clicks in our viewer, we can easily jump between what we're viewing. It makes it really easy to work with assemblies or parts that have been cut up in a various ways. So once we've got cut, now we have multiple parts. Usually we want to keep some form of information tracking. Materialise has some great tools for adding labels. Click, drag. can define our text box. We can either do embossed or engraved lettering. And this generates itself into the STL. Just a couple clicks. No hassle. We can go back and do this on the other part. And we have our labeled parts. Now, one other thing that can be really difficult and something that can really help how we build our parts is adding fillets and chamfers. Usually that requires us going back into CAD, adding those features, re-exporting out, sending them back to the printer. Very slow process. With this last update, Materialise has added the chamfer tool, so now we have both filleting and chamfering available. And we can apply that directly to our STLs. So a great way to modify your prints without having to go back and forth with anybody else or back and forth between any softwares. Materialise also has tools for prop generation. Say you have some thin-walled parts or some delicate structures that you're printing, and you think that they'll warp either in a secondary process or during printing. We can easily go through at a couple points and create these structures to help solidify our part and keep any warping to a minimum during our printing processes or secondary processes. And these are customizable in size and style. So for this, I don't think we really need that part, but it is a great feature, especially if you're doing like flanges or something on a powder bed system. Another tool that I like is we know 3D printing has its surface qualities. This is just kind of innate to the technology. We have layer lines or slight changes. Yes, with stereolithography, we can get very fine details and nice sharp edges, but sometimes we need a machined perfect finish. Materialise has a great tool where we can add machining offsets so that it automatically generates an area on whatever surface we select so that we add on material to so that we can then machine that feature to size. Now, for those who use Polyjet, having separate shells or separate bodies is a pretty big deal if you're trying to apply multiple colors. We can come in and use our selection tools to select different parts per surface. We can paint these parts. We can paint them a few different colors. And we can then go up here and easily split those parts into multiple bodies. So that once we transfer over to our Polyjet preparation software, we can apply those new colors within that, but we can quickly separate our shells out. Now, if you are working with a more complex texture and you're not just doing colors applied in your slicing software, we can also select areas of the part and apply our own textures. Materialise has some great tools for setting orientation and applying these textures. So a great way to colorize parts for CMF production or anything that has color verification required. In terms of other tools that come with Materialise, we can analyze our parts for both trapped volumes so that we have some kind of warning if we are going to be printing with a powder or vat system. So this solver will go through and tell us if we have any kind of cavity, anything that's come up from our editing, things like that. For this part, we should be safe, but we'll let the solver run anyways. And we can see our part, and we can see we don't actually have any captive volumes, so we only have our one body. Another great tool is the Build Risk Advisor. So it's going to be detecting for large changes in the layer densities and other factors that can affect your build success. Definitely comes into play for, as I said, powdered systems. And as well, you do have a check slice distribution that will show the area change between your layers. So if you're working with a metal sintered system, that can tell you and warn you if you're going to have any kind of part warpage because of the drastic change in thermal load on your print. Now, if we want to go in, say we only have an STL for a part and we want to know more of what we're working with, we do have typical bounding box, center of gravity, and other dimensional statistics for our parts. We can also go in and take measurements. So we can use this as an analysis tool as well. So if you're only working with STL and you don't have access to the CAD, this can be a really powerful tool to change, edit, and improve what you can do. So what I'll leave with you guys today is I want to talk a little bit about some of the other modules available that can support Materialise Magics. One of the really powerful and cool ones are the Honeycomb Structures and Structures tools. And these are pretty computationally heavy tools, But the Honeycomb is basically a version of the shell tool that builds a honeycomb pattern normal to whatever orientation you define, but will shell out the selected area. So you have this exposed honeycomb structure. So it's a very impactful visually and impactful in terms of weight reduction on parts while still maintaining a large amount of the part strength. So, a very cool tool. And then the structures is a tool that allows you to do very complex unit-based infills on your parts. As I said, these are both very computationally heavy tools, so I don't want us just sitting here for 5-10 minutes looking at loading bars. We'll let this create a quick mesh, and I can show you kind of what those different unit cells are available by default. And Magics does allow you to build these on your own. So you can import your own custom unit cells and apply those. While we let this run, if you guys have any questions, feel free to add those into the chat box.
Hey, Collin, we do have one question that came through while it's going. It's kind of pertaining to this model. If you want to take the second to answer it now. The image you have on your screen is a texture applied to the body, the STL. Is that, are we able to take that out and use it on the new J55 for the full color printing?
Yes, absolutely. From Magics, we can export as WRLs or VMRLs, so we can preserve that texture wrapping on our mesh data so that when we send it over to the printer, we have that still applied. We also can export as 3MFs.
Awesome.
So here are some examples of the complex infill structures. So you can kind of imagine this running throughout the part. Can really open up some possibilities in terms of weight reduction and things like that for your parts, and can create some very interesting and eye-catching designs. Last I will show you is another very, very powerful tool. This is an added module, but it is support generation. And now you can do our short support generation. Sorry, I'm having some technical difficulties. I seem to have misplaced my support type. There we go. And we can do various types of support for trees, more platform style supports, and things like that. And the normal support generation function that is designed for polymer systems. And then there is the support generation plus system for metals. So this allows us to go in and we can edit any and all of our supports, define them how we want. And if you control which sections get support. Again, sorry, I believe WebEx is. Did we have any other questions, Jeremy?
Yeah, there's actually a few questions. I was trying to keep them to pertain what you're working on. One of them is in regards to the pins and holes, the alignment thing that you were doing with the pins. Was there a way to the ability to adjust the tolerances on those? You know, some orientations you might need a different tolerance, or even some materials might require different tolerances. Does they give you the control to change those?
Yes, absolutely. You have control over the size of the pins, spacings, what kind of gap you leave between the pins. So if you're trying to leave room between the two parts for epoxy or other bonding method. And you can even control the mesh resolution for those pins that are generated. So that'll determine how your cylinder is truncated by the triangular mesh. So, and here's an example of those supports. We can go through our part and see all the different areas where it's defined as some type of support is needed. And we can edit by supported area of those. And we can change the diameters and sizes of our mesh and trees in this case. So Magics is a very powerful tool. You can do a lot of different editing functions, modifications, things like that. And that's all done to STLs. You can import CAD files and other parametric models into Magics. There's an import module upgrade you can have, so you can import most everything in, and Magics will convert all of those files into a mesh so that then you can do whatever kind of editing you want, whether it's the complex supports or structures or something like that, texture mapping or texture wrapping. Or you can just have the STL file and apply all those things, which usually when you have an STL, you're kind of locked out in what you can do. So hopefully I've conveyed the power Materialise has, and if you guys are interested, please feel free to reach out to us more, or if you have any questions, I'd be happy to answer them now.